Okay, hi everyone. Now we are going to discuss about volumetric analysis VIVA for class 11 and 12. This is part 2 video. In this video we'll be discussing about more VIVA questions on volumetric analysis. Please do make sure that you have watched the part 1 video of volumetric analysis. Now let's start with the part 2. The question number 15 which we are going to discuss is, what is meant by the term concordant reading? In the previous video, that is part 1, we had discussed 14 questions with detailed explanation, right? Okay, now we are going to discuss about the 15th question, that is, what is the meaning of concordant reading? Concordant reading. This term, all of you might be familiar in your titration process. Whenever you are making your table of titration, you have seen that the volume of KMnO4 used or your reagent used when you make the table. In the left side you know how to make the table. In the right side when you write the burette reading, this is your burette reading. You always used to do the experiment many times. For example, first time I'm getting the volume as 10.25 milliliter. Imagine this is just a rough value, okay? 10.25 milliliter as your burette reading on completing the redox titration. Imagine second time when you are doing, you are getting 10.6 milliliter. Check, can we consider this both as our result? No. Concordant reading means it is a reading, that is two consecutive readings that differ by less than 0.05 milliliter. So if we are getting two continuous readings that differ by only 0.05 milliliter or less, then only we can consider it as concordant reading. Here you can see their difference is actually large. There is large difference. That is, difference is greater than 0.05 milliliter. So we cannot consider it as concordant. So this is not concordant reading. Right. So let's imagine one another value for concordant reading. It is 10.25 or 249. 10.249. If I am getting 10.249 milliliter, approximately I can tell it as 10.25 milliliter, right? These readings are very similar to each other, right? That means their error is actually very less, and you can consider that this is concordant reading. So we can define concordant reading as a reading which differ by less than 0.05 milliliter, and we are getting concordant readings like this. We can say that our burette reading is 10.25 milliliter of the reagent KMnO4 which is used. This was our 15th question. Let's move to the next question, question number 16. Let's see. Can one take oxalic acid solution in the burette and sodium hydroxide solution in the titration flask? What are the limitations of doing so, if any? Generally, we know that. How do we do the titration? Oxalic acid. How do we do the titration generally? Oxalic acid. General principle is oxalic acid is taken in the titration flask. And which is taken in burette? KMnO4 solution is taken in burette, right? And this is our standard procedure. But they are asking, can we switch the reagents in different apparatus? That is, can we apply oxalic acid in burette and KMnO4 in titration flask? I'm just writing short form, titration flask. Is this possible? This is the question. You know that the reagents are taken and redox reaction is occurring. Anyway, redox reaction will occur if you use the first method or second method, but the problem is in the observation of the result. Here the final color obtained is pale pink color, permanent pale pink. Permanent pale pink color is obtained when you use the first type. Type 1, if you are using, you are getting permanent pale pink color. But when you are undergoing the second type of reaction, you know that in your titration flask you are already taking KMnO4. So it's already pink. So if you're adding oxalic acid and finding permanent pale pink color will be again difficult because the reagent itself is pink. So observing pale pink color will be very difficult. So observation of endpoint will be difficult. So we will say that the endpoint observation is very difficult in case of the second method. So we are not using the second method. So I hope you understood this second question. I mean the 16th question. Okay, second question of part 3. Sorry, part 2. Okay, now next is question number 17. That is actually important to remember. Which indicator can you use for sodium carbonate Na2CO3 versus HCl titration? Which reagents are sodium carbonate and HCl? This is which type of reaction? Acid and base reaction. This is redox chemistry only. Acid reacting with the base is also redox reaction. So in this type of redox reaction, which indicator can you use? The answer is, the reagent which is used is methyl orange. Methyl orange. Why? Or if they can ask you what is the color change, this you should remember. Methyl orange is the indicator and the color change is obtained from yellow color. Methyl orange, it is changing from yellow to pinkish red. This color change you should always remember. This generally asked as a VIVA question. Okay. Next question is, which indicator you are using in the titration of oxalic acid with sodium hydroxide? This is your grade 11 titration, right? Grade 11 also in many schools you are doing this type of titrations. That is, which indicator you are using for question number 18? It is question number 18. Which indicator you are using for oxalic acid titration with sodium hydroxide? This is your reaction. This is acid and this is your base. So acid and base reaction is redox reaction. So this is redox chemistry titration. And which reagent can you use? Can you tell me a reagent which can change its color in the acidic medium and basic medium? Which reagent could be that? Do you know any reagent like that? Yes, your guess is correct. Oxalic acid in acidic medium, phenolphthalein we are using. Phenolphthalein is the indicator which shows colorless in acidic medium, and when the reaction is complete, then small amount of NaOH, when it becomes excess, it changes its color into permanent pale pink color. So I hope you understood. Permanent, writing short form, permanent pale pink color is obtained. So whenever you are getting acid base reactions, you are generally using phenolphthalein, especially for colorless reagents. Oxalic acid and sodium hydroxide both are colorless, so identification of the base can be done by phenolphthalein easily. And so the indicator which we are preferring is phenolphthalein for which titration? Titration of oxalic acid with sodium hydroxide. So I hope that is the thing. And they can ask about what is the endpoint. Endpoint will be the observation of permanent pale pink color. So pale pink is very important, and this indicates that the reaction is just complete. So that was your 18th VIVA question. Okay, let's see what is the next VIVA question. What is the meaning of, this is your 19th question, I hope so. The question is, what is the meaning of acidity and basicity? Acidity of an acid. Sorry, acidity of a base. Acidity of a base. What is the meaning of acidity of a base? We know base, for example, sodium hydroxide is a base, right? You know very different types of bases, sodium hydroxide, potassium hydroxide, many types of bases, right? Sodium hydroxide is a base. Why do we call it as a base? Because it can give OH minus ion in its aqueous solution. So if I'm adding to water, this furnishes OH minus ion here, and sodium positive ions are also produced, right? This OH minus ion is known as your hydroxyl ion. How much hydroxyl ions can be generated by 1 mole of a base, that is said to be acidity. So number of moles of hydroxyl ion, OH minus ion produced, that is known as your basicity. Sorry, not basicity, I mean, what was it? It is acidity. So it is acidity. Acidity of base. Right? So acidity of a base can be defined as the number of moles of hydroxyl ion produced when 1 mole of the base is undergoing reaction with water, that is hydrolysis reaction. Then what is the meaning of basicity of an acid? So how can we write basicity of an acid? We'll just change the words. Acidity of a base we are just replacing, and we can write it as what? Basicity of an acid. What is the meaning of that thing? Basicity of an acid. Basicity of an acid. It is the number of H plus ions produced. That's a simple definition of basicity of an acid. For example, hydrochloric acid we'll consider what is the basicity. Sulphuric acid we can consider what is the basicity. Hydrochloric acid can ionize 1 proton and Cl minus ion. So how many protons generated? 1. So it is 1 basic. So I will call monobasic acid. Monobasic acid. And this can generate 2 protons and SO4 2 minus. Right? So this is producing 2 protons. So it is dibasic acid. Right? So this is said to be basicity of an acid. How much H plus ions are produced by an acid is said to be the basicity of an acid. So this VIVA question also, I hope you are well clear about it. Let's see this. I hope you understood it nicely. Now 20th question, VIVA question. I am discussing the important VIVA questions. Okay. What is the relationship between equivalent mass of an acid and its molecular mass? Equivalent mass, relation between equivalent what? Equivalent mass of acid and its molecular mass. We studied that in our definition of equivalent mass. We studied equivalent mass. I am denoting by EQ mass. This is your equivalent mass, is your molar mass. Molar mass divided by the number of ions transferred. Number of ion means, in case of acid, which ion we are discussing? It's H plus ions, right? H plus ion only we are discussing. That is its basicity. So this is the relationship between equivalent mass and molar mass. For example, we can say equivalent mass of sulfuric acid or hydrochloric acid, anything. Hydrochloric acid, if I am telling, it is H plus and Cl minus ion produced. So equivalent mass of hydrochloric acid is nothing but molar mass of hydrochloric acid divided by basicity. It is monobasic, so it is 1. So it is same as the molar mass of HCl, that is 1, plus molar mass of chlorine is 35.5, that is 36.5 gram per mole, indicate the equivalent mass of hydrochloric acid, which is same as its molecular mass, because basicity is said to be 1 because HCl is a monobasic acid. So this is the concept regarding that VIVA question. Now which VIVA question we are going to discuss? 21st VIVA question we are going to discuss. Only important things I will discuss, because other questions are basically same. In a sense, it will be very similar to each other. And another thing what I want to discuss is the structure of some very common acids also. It is important. They can ask you in the VIVA questions. Structure of acids. For example, of some acids, which you have to remember always, the structure is structure of hydrochloric acid. Hydrochloric acid structure, very simple. It is hydrogen bonded with chlorine. You know this very well. And is this a polar molecule or not? Yes, it is polar molecule. Yes, polar. Why it is polar molecule? It is dipole moment present. Dipole moment is present. How we can say dipole moment is present? In this molecule, this shared pair of electrons, these two electrons are shared pair of electrons. This is actually attracted more by the chlorine because chlorine is more electronegative. This chlorine is electronegative. That means it will try to attract both the electron, shared pair of electron towards the chlorine. So this chlorine develops delta negative. So this develops a small positive charge. So we can say that positive charge and negative charge is present within the same molecule. So this is a polar molecule. That means dipole or polarity is present. So HCl, the structure of HCl, and it's a polar molecule, we know. Now next acid is your sulfuric acid. H2SO4 is your sulfuric acid, or the king of acids. Sulfuric acid, its structure is S double bond O double bond O, and one OH is produced connected this like this, and here also one OH. Right? Here you have to remember one thing. If ionizable hydrogen is present in the form of OH ions and is connected to the central metal, non-metal here, this such type of acids are known as oxyacids. Oxyacids, right? Okay. Then now we are going to study about another. This 2 hydrogen, you know, it is ionizable, right? So that you should always keep in mind. Now we are going to study about the structure of nitric acid, another important acid, nitric acid. You know about nitric acid, right? What is nitric acid? HNO3. HNO3 is your nitric acid. The structure of nitric acid is important. Always keep in mind the structure of nitric acid is nitrogen is connected with double bond O to oxygen, and here it is having one oxygen connected like this OH group, and one more oxygen is connected like this. So this is the structure of nitric acid. Always remember, here the central nitrogen is having a positive charge and this oxygen is having a negative charge. This is actually coordinate bonding. You know about coordinate bonding, right? So this negative charge and positive charges, they compensate each other, and overall it's a neutral molecule. And how this is a monobasic acid because it can ionize only one hydrogen. This is monobasic acid, whereas your sulfuric acid was your dibasic acid. Dibasic acid, and your hydrochloric acid is also monobasic acid. So this 3 concepts you should keep in mind. Generally they ask about these 3 things. Okay, then your VIVA question, your first type of VIVA questions we have discussed, that is your volumetric analysis VIVA questions. Now we are going to discuss some more important volumetric analysis questions based upon your grade 11 and 12. Generally 11 and 12 related volumetric analysis questions are asked together. It does not depend upon whether you are in grade 12 or 11. Okay, so let's see some VIVA questions regarding volumetric analysis. Why is phenolphthalein added to the solution in titration flask? The question is, why is phenolphthalein added? What is the peculiarity of phenolphthalein? Simple question, right? Phenolphthalein, why it is added to the titration flask? The answer of this will be, why it is added? Phenolphthalein is added because it is a indicator which changes its color from colorless in acidic medium to pale pink color at end point of the reaction. End point, it produces pale pink color because small amount of base is present. Okay, so this is the use of phenolphthalein. Okay, why you should not hold pipette in its bulb while transferring the liquid? Why pipette must not be held by its bulb? We know very well pipette is similar structure like this. I'm not drawing properly, I think. See, like the structure, this is a pipette. In this pipette, imagine this is a pipette, and in this pipette we are not supposed to hold the pipette in this bulb. This is a bulb of the pipette. Why we are not supposed to touch or hold the pipette by its bulb? Because we know that on holding the bulb of the pipette, we know it is made up of glass, right? The pipette is made up of a material that is glass. Pipette is made up of glass, and glass can expand on being heated. Glass heated in a sense your body temperature. Your body temperature can cause what? Can cause expansion of the glass. Expansion of glass. Small value only, okay? Minute delta volume or small amount of volume can increase in the pipette. That means there will be changes in the volume of the liquid which is taken in the pipette, right? Instead of 20 ml you are pipetting out, sometimes due to the expansion of the glass you may be taking 20.01 milliliter or 20.1 milliliter of the reagent. So this small variation is actually causing error in your answer. So in order to prevent that, we are not supposed to hold the pipette by its bulb. This you should always keep in mind. So this is one thing. Then let's see some other questions regarding it. What is the equivalent weight of sodium hydroxide? The next VIVA question, that is your 24th VIVA question, right? 24th VIVA question is important. What is the equivalent weight? Equivalent weight of sodium hydroxide. What is equivalent weight of sodium hydroxide? So sodium hydroxide equivalent weight, to understand we should know what is the meaning of equivalent weight. Equivalent weight of base. Equivalent weight, just writing short form, equivalent weight is molar mass of a particular base divided by its acidity. This is known as equivalent weight, right? Acidity we know, sodium hydroxide can ionize to form sodium ions and OH minus ions. So how many OH minus ion is produced? This is 1. So 1 OH minus means its acidity is 1. So I can write equivalent weight is same as molar mass of sodium hydroxide divided by 1. So this is molar mass of sodium hydroxide, that is 23, plus molar mass of oxygen is 16 plus hydrogen 1. So on solving you will be getting 40 gram per mole. 40. So generally we are not writing gram per mole here, it doesn't matter. So we will just write the equivalent weight of sodium hydroxide is 40, and sodium hydroxide is which type of base? This which is acidity 1. So I can say it is monoacidic base. Monoacidic base. So justify sodium hydroxide is a monoacidic base. So this is a meaning. Okay. So let's see some other calculations. Let's see what is methyl orange. Methyl orange, that's a good question. What is the meaning of methyl orange? Methyl orange is an indicator, we know, but you have to tell about what is a chemically what is methyl orange other than an indicator. So this is your 25th question, right? 25th question is, what is methyl orange chemically? This question is important. We all know that it is a chemical indicator. So that is not the expected answer, because this is very commonly known. It is an indicator, but you have to say that this is a sodium salt of an azo dye. This is sodium salt of an azo dye. What is an azo dye? Azo dye is nothing but aniline, right? Aniline. I am telling what is an azo dye. This has nothing to do with methyl orange directly right now. I am just telling what is the meaning of an azo dye. Azo dyes are of different types. They are colored substances. Azo dye are colored substances, colored compounds in a sense, colored organic compounds. Okay. So what is the meaning of azo dye? I will give an example. There is a chemical compound known as aniline. Aniline is nothing but benzene connected to an NH2 group. NH2 group, this is aniline. This aniline, if I react with NaNO2, sodium nitrate and HCl under 0 to 5 degrees Celsius, if I undergo this particular reaction, the product formed is like this, N2 plus Cl minus. This I am just telling you to have an idea about what is azo dye, but no need to memorize this right now. Just have an understanding of it. This is compound known as diazonium salt. Okay, diazonium salt. This diazonium salt, I am reacting it back with aniline. This aniline I can write in another way also, right? This aniline. Okay, I will write about diazonium salt reaction. Diazonium salt I am writing, this is your diazonium salt, N double bond N Cl. Here it is N2 plus Cl minus. In a sense I am writing like this only, not a problem. N2 plus Cl minus. This diazonium salt, this is your diazonium salt or diazonium chloride. Diazonium chloride, I am going to react it with your initial compound, that is your aniline. Aniline is nothing but hydrogen connected to benzene group and it is connected to NH2 group. This and this both are same, because anyway here one hydrogen is present, right? That hydrogen I wrote in just twisted the molecule and wrote like this. Okay, after reaction what happens is this hydrogen and this chlorine combine to form HCl. That HCl I am removing from the apparatus. Then what is formed? The compound which is formed is like this. Like this, as it is, you write this part, you write as it is, N double bond N, and this part after removing the HCl you connect it with the next benzene ring, and this is connected with NH2. This compound is known as your diazonium salt produced compound, that is your azo dye. This is a colored compound. This colored compound is known as your azo dye. Azo dye is nothing but colored compound. Colored compound. So this is the basic idea. So what was the purpose of telling all these things is, what is methyl orange is chemically it is an indicator which changes its color at the end point. End point it changes its color and it is a sodium salt of an azo dye. So this azo dye reacts with sodium to form sodium salt. Different types of azo dyes are present, and this is one yellow colored azo dye. So like that, one after reaction with sodium we are getting methyl orange. Different types of azo dyes are present and we are taking it like that. Okay, so that is the basic thing. Then how can you distinguish between the 26th question? Okay, 26th question is, how can you distinguish, or what are the differences between oxidation and reduction? Oxidation and reduction, these are important redox chemistry based VIVA questions. Reduction. So what is the difference between oxidation and reduction? To understand this, there is a popular mnemonics. You remember oil rig. Oil rig. Remember like that. This is nothing but oxidation. O stands for oxidation. Oxidation. I stands for is. L stands for loss. Oxidation is loss of electron. Reduction is gain of electron. So R stands for reduction. Reduction is G stands for gain of electron. This is the basic idea behind what is the difference between oxidation and reduction. So let's see. Based upon this we can say oxidation is nothing but loss of electron and reduction is nothing but gain of electron. Oxidation can be addition of oxygen and reduction can be removal of oxygen. Just opposite. Removal of oxygen. Don't write O2. It's better you write oxygen. Simply oxygen. That's only more appropriate. Oxygen. And oxidation can be, here you remember, reduction can be addition of hydrogen. Addition of hydrogen. And this will be removal of hydrogen. And one more difference is in oxidation number. Oxidation number increases. And in reduction, oxidation number of the central element decreases. So these are the basic ideas, but the most important of those is your first statement. If you know the first statement, then you don't need to worry. You know all the things about redox chemistry. Okay, then next question is also very very important. 27th question, right? I hope so. 27th question is, why do we heat oxalic acid solution to 60 to 70 degree? Why do we heat oxalic acid solution to 60 to 70 degrees Celsius? What's the purpose of doing that? We know in your this question is coming from your grade 12, but still for grade 11 students also it is important, because VIVA questions are all based on the same concept, that is your redox chemistry and titration. So you can expect questions also. We know that rate of a reaction, the answer is, when you are saying, you have to say that the reaction on increasing temperature, that is when temperature increases, rate of reaction increases. Whenever you are applying more heat or temperature increasing, the molecules gain enough kinetic energy and they take part in the reaction, right? So when you are increasing the temperature, your rate of the reaction increases. And if they are asking you the evidence, you say the equation rate constant K equal to A into e raised to minus Ca by RT. So we can say that this is your equation of our rate constant K. This is your Arrhenius equation. This is Arrhenius factor, and this is your exponent in mathematics, and Ea is your activation energy, R is your gas constant, and T is your temperature. So whenever you are telling, or I will tell you, whenever the temperature is increasing, the rate constant K of the reaction increases. K increases. That is your rate constant. Rate constant, nothing but the rate. How the rate varies. Okay. So simple words. Whenever you are increasing the temperature, the oxalic acid molecules gain enough kinetic energy to take part in the chemical reaction. So in order to increase the rate of the chemical reaction, we heat oxalic acid solution to 60 to 70 degree Celsius. And always remember the structure of oxalic acid molecule. What is the structure of oxalic acid? Oxalic acid is nothing but COOH. Carboxylic acid to carboxylic acid molecules are attached, and 2H2O, that's your hydrated. Okay, this is the structure of oxalic acid. COOH connected to COH, and 2H2O molecules are attached. So this is all about some main VIVA questions which I have discussed regarding it. So I hope you understood, and in the part 3 of the volumetric analysis, I will be discussing about how do you balance when you are writing ionic equation and molecular equation for your redox titrations. In your volumetric analysis, both molecular equation and ionic equations are present, and I will be giving you tips or tricks through which you can memorize, not memorize in a sense, you can find out the balanced equation easily. Okay, I will be giving you tips and tricks. So stay tuned for that, and please do like, share and subscribe, and please do watch the next video also. This is Abhishek. Thanks.